Thank you, Jessica. And to clarify, I'll talk about the very early ones. You know, I can't just possibly even try to cover 40 years. So, and you could see our history of our logo. It has improved, I think. It's pretty nice now. So just a few words about, oh, that's interesting. So why isn't it working? There we go. Well, that's what we'll do. So a few words about me. I grew up in the north of France, and then I studied in Lille, and then I studied in Paris. And I worked on a thesis that was speech recognition to help disabled people who could not move, just barely could say press a yes or no button. And it used a microphone for voice, and you could put a bunch of devices behind and give commands such as turn on the light, turn off the light, or raise my bed, lower it. And just to put through in the context, so we were using little computers like this, and we had like incredibly very little space for anything. So for example, I did everything in assembly language so that it would fit in there. So then I went to work in a nice place in Paris, met my American husband, came here. Oh no, we did things for children actually, just to give you, and we used at that time a very advanced user interface system, input device, which was a light pen. We're talking 83, 84, a light pen where you could touch and interact with the screen and create displays like this. So after that, I went to the USC. You know, my husband convinced me to come. I wasn't sure, but you know, it worked out. And I knew about this book from Ben Schneiderman, and at that time there was no internet. There was internet, there was email, but there was no web. So to find out where the place in the US or in DC that are working on the human-computer interaction, I had learned the word at least, I went to the Library of Congress and searched their catalogs of university labs, and everything pointed to Ben. So I started the HCIL in 1987. Many of you were probably not born. So, and today I'll describe some of the earliest projects and try to trace some of those early works to today's design. So again, when I started in the lab, we were reading emails in machines like this, and then you went across the hallway to go to the lab who had PCs, and of course they were not really connected. And then you use things like floppy disk to save your work and move it from one machine to the other, just to give you an idea of what those things are. And just everything I'm going to talk about today is actually fairly well documented in our website. This is a new look of the website today. There is an archive section with early themes and all the research projects. Everything is well documented in there. And we could come back to the value of this. There is also an history bookshelf that I tried to clean up recently with a lot of artifacts that we might talk about today. But let's go to the first project. When I came to the lab, I was hired to work on our hypertext work. And Ben had been already developing a system called Hypertize, and it had what's called, Ben and his students had invented the highlighted embedded links. There is a paper. And the embedded links, you're very familiar with it, you use it every day. It's those links, those highlighted words that appear now in web pages, and then you think you click on it and go somewhere else. So hypertext already existed. It was the idea of connected bits of information with links. But before that, before the embedded links, typically you would read about something. So here was a description of a picture, and then you would have a menu saying, would you like to learn about this person or this person or this person? And then you would say, enter a single number or letter to go to follow those links. We are singing mouse, but the mouse was invented, but nobody had any, it was not out there. So the idea of the embedded link was a big jump in, making it a lot easier to follow those links. So here is an example. The other thing to keep in mind, because there was no mouse, and it's more visible here, like one link was highlighted, and you would use the arrow key to go up, and you would jump to cost, and up to here, and up, down, 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 right, left. That's how you navigated before mice. Yes. So, and one very important application, and actually I should say a commercial tool called, developed Hypertize. So it was available, people could buy it, but everything was running locally. Remember, no web. And one very important step was to create an Hypertize version of a special issue of the ACM on hypertext. So, and here is a box that you could get with your copy of CACM, and there was a floppy disk with the hypertext version of this CACM. Yeah. And what happened is that when Tim Berners-Lee described his manifesto for the web, he refers to this, and he had seen it. So, surprise, all the links of the web use those embedded links, and surprise, they're even blue still. I remember there was one of the first experiments we did in the lab. I was doing this one. We changed the colors and what color would be best, and blue was the best. And surprise, it's still blue, by default. It's interesting. So I mentioned this. So you could read more online, and one of our pages is about this project, which in a way give a hint, or a lot of the work we do, we just do the paper, but sometimes there is a whole story that goes around it. And if you document it and put it in a web page somewhere that will not disappear when you graduate, others could read about it in the future. So any question about this one? Should I move on? I'll move on. So the next topics that became a big topic in the lab was touchscreen user interfaces. And you could get an idea what it looked like actually at the time. There was no phone, there was no tablets. We were on the computer screens, and some vendors would mount a touchscreen in front of it. So to pick one example, because you are very familiar with it, so one of the many applications we did for touchscreen was the miniature keyboard that now you are all using every day. But what's important is that at the time, the guidelines, everybody believed that you could not make any button that was smaller than your finger, and even a big finger, because there are people with big finger. So, and then because practically you would touch the screen and you would immediately do something, boom, activate. And of course, you would always hit the wrong place. It was not calibrated. It was a lot of errors. So you have to make big buttons. But very cleverly, I think that was Richard Potter, Benjamin Benz, HCIL students developed a technique for lift-off selection. So you would touch, as you could see here, and you could use it on your phone to try it. It never activates immediately. You touch, and it's when you lift off that it actually activates. So you could adjust the position. And that made the touchscreens suddenly very useful. And we showed that you could select down to a pixel. Of course, our pixels were bigger then, so it was a little bit easier. But still, you could select, it was high precision touchscreen. So, so that was, that's an example where the early work clearly found its way in the products. Of course, we don't know, but somebody else could have invented it too. But we have, we know that the Steve Jobs of the world actually would come visit the lab in person, because that's the only way you could really see those demos. The other way we would, of course, we had technical reports before the things would go in the magazine, in the journals. We also had every year, starting in 1991, every year for the open house, we made a video, and people would send us little postcards saying, could I have a copy of the video or a copy of this tech report number, blah, blah, blah. And we would mail them back to them in, physical objects. So this is one way we really very early as a human-computer interaction lab disseminated widely our work and made it very well known, is by distributing, making it easy to see the demos of those prototypes. Alors, so I switched to another one, which is at the time also I'm trying to show how we start those projects. So we had the state of Maryland has a program called MIPS that helps support labs like you to work with companies, usually startups. So in that case, it was a startup called Custom Command that did home automation system way before it became really common. And unfortunately, they didn't make it. Clearly, the market wasn't there or the technology wasn't quite right. But they would control everything in the house of very rich people with touchscreens in the wall or even with voice. And so we did several of their projects for them. One of them was to help schedule devices, they're like your furnace to go on and off. So you would have an interface like this with little buttons. But we also made one with you could select a pair in a calendar and you move the watch, the end of the watch to set the start time or the stop time. Or we showed you could drag little icons. I don't even have a good picture of it, but red icons and put them on a timelines. So those were very early interaction, showing direct manipulation with touchscreens that, were seen by most of a lot of the researchers in HCI. So then I'll show you a little video that is, it's really funny. It's a small project. We didn't have a paper for it, just a video. But somehow this is why one of my work was the most well-known because it ended up in a big legal fight. So let me show a little, a little video. And actually, maybe it's better to show this first. The idea is that you'll see a touchscreen slider. And there was a big fight because the Mac used a slide to unlock. And they attacked Samsung and other vendors for saying, you can't use that, we invented it first. So somebody digged up the old, as they call it, a grainy video showing me using my little slider, and it was used in that big battle for years and years. So somehow this video is very well known. So I thought I could show you a little bit because it also shows how we made those demos at the time. And we'll stop it before the end, and I could accelerate it a little bit. So this is one of the earliest video in the first video we made.
Hello, I am Catherine Plaisant from the Human Computer Interaction Laboratory of the University of Maryland. I will be discussing the design of touchscreen toggle switches for novice users. Toggle switches are those buttons, levers, sliders that allow us to directly turn on and off lights, radios, TVs, and any other type of devices. Computers now allow the design of new type of toggle switches. However, there are still many inadequate designs that can be found in existing systems. For example, here, it is quasi impossible to say what the status of the toggle is. On, off, nobody is really sure. Here, the box is a good clue. But this shows a classic problem. I don't really know if the box around the on indicates that the device is on, or if the box indicates where to touch to turn the device on. Another problem is that the toggle has to be identifiable as a toggle. Is this just a label, or is it a toggle? If I touch quit, I'll probably quit. So if I touch on, the device might turn on. Or is it already on? Those are the type of problems encountered by novice or first-time users, and we wish to address those.
I'm going to, just for interest of time, I'm going to switch. Here you could see
with Custom Command Systems, a small Maryland company.
And then we could see some of the demos.
Locate the device and the menu structure, and then manipulate the toggle. For example, here you see the one-button toggles.
And then we could switch in some of the other ones, like this one.
Version. The motion fits well with the finger's gesture. With the slider toggle, the slider has to move from one side to the other. Same principle for the lever toggle. Having to use a sliding gesture makes the toggle slightly more difficult to use, but greatly reduce the chances of advertently switch the toggle. We ran a usability study.
Of course, we always run a usability study, compare those toggles. But so I'll stop this for today. But all those videos are also online in the archive area of the website. You know, it's kind of a fun story. So that's an example where really we didn't think it was important, but if we had not recorded it or not documented, you know, or work, it's as if you had never done it. So always think, you know, you never know what's going to happen with your project. Make sure it's available out there and that people could find it, and that it will, again, that will not disappear when you graduate, because that's the most common mistake. You know, they just go away. So the HCIL site has been really useful as keeping all that information. I think, unfortunately, now I don't think we have it. It's spread out everywhere. Maybe it's still okay, but think about that. You know, make sure at least it's findable. So I'll switch to something completely different. So dynamic query the goal was to apply direct manipulation principles to search. So with the first demo, we also became very famous. We still don't have the web here. We're talking still demos inside. Was the home finder, which is was to help people find a house, an apartment. And so we wanted a realistic scenario. So one of the students actually took the Washington Post and retyped all the information of all the houses for rent, for sale, and put it in the demo. So for fun, I'm gonna just to give you an idea, that was the team at the time. We're not very big yet. And oh no, I'm going, what did I do? Oh, here we go. I wanted to show you the actual demo. So we could go to here. And I don't know where to go.
With 15 subjects, they were given representative tasks.
What's this one? Where's this one? I have been queued up here, so it's been doing the demo, and we'll make it big. And the idea is that, you know, this is the DC, very simplified. Every house is a dot on the map, and you're gonna work downtown, and your spice is gonna work at the University of Maryland, and see how people would search.
On the display represent a home for sale. And if I move to the right, I can control this display by choosing the distance that I want to be from point A. And now it's set at 30 miles, and I'm going to bring it down. And you can control rapidly, incrementally, and reversibly the distance that you wish to be from point A. So let's say you decide, you see there's plenty of them, so you say you want to be, let's say, 5 miles from work so that you could, let's say, bike to work. And now you want to be somewhere inside that range from B, so you slide down and we now can see the set. And this looks like we've got about 40 or 50 homes over there. If I now choose about the number of bedrooms, I really want 3 or 4 bedrooms, so I move this double box slider to be 3 or 4. I've still got about 30 houses on the display, so why don't we look at the price now, and we want to keep the price down, let's say about 170,000, between 140 and 170,000. And that's given us a set of about a dozen here. We could trim a little further by choosing. We can choose from houses, townhouses, or condominiums. Let's eliminate the townhouses and condominiums, so we're selecting only houses. Yellow indicates selected fields, and I can see now I've got about 10 of them. If I click on any one of those points, if I just click here, then the bottom of the display gives me a description of that house. In Tacoma Park, a newer middle-class neighborhood, colonial brick, and fireplace, garage, etc. This gives you a way of posing a very specific query, seeing the feedback immediately, and getting an answer to your question, plus reformulating your goals as you see the results of this query. Now, another way to use this display is to explore. And here, if you see the whole area of Washington and you want to see different neighborhoods, and let's look for high-priced neighborhoods. I can see them dropping out here, or I can see them if I move here and just leave the high-priced ones, Potomac, Silver Spring, Fairfax, Virginia. So you might ask yourself the question, is there a correlation with bedroom size, with house size, the number of bedrooms? Do you expect to have large houses only in some neighborhoods? Well, let's find out. And the answer is no. They're distributed quite uniformly.
And I'm going to stop here for interest of time. But really, you have to think that this was completely unseen. Typically, you would type a query, very complicated, and wait and get an answer, and you have to. So the idea is to do like 100 queries per second. So that video has been seen a lot, right? And so eventually, the next step was to think, okay, this was great, but we could replace the map by something else. And that led to the film finder. I'm very simplifying here, but you could, all those dots were films, and you could again select with the sliders and the buttons, but you could also change what was on the X and Y axis, so year of production versus the popularity in this case, and see different things. And so that was really a very important demo also to, highly cited papers for everything that linked to interactive visualization or data exploration. So in that case, the Swedish student who had come to do the demo just before the film finder went back to his country and started a company, and eventually moved to the US. So the tool is called Spotfire. It's funny that you're in the way here. What's happening here? Anyway, Spotfire. Let me try to get rid of this because that will help. It's here somewhere. Voilà. So Spotfire. And it was really a big success as a company, as in terms of data visualization tools. It was used by their first segment of the market was drug discovery. So all the major pharmaceutical companies were using Spotfire, or actually probably still using it now. It was sold to a company called Tipco. So it's not a tool that we hear very often. Now we always hear about Tableau, but this was and it's still used a lot too. But Tableau is more accessible to everybody. You could get a free demo as a student, so you hear a lot about it. But Spotfire are the major, one of the lead really of those tools. And yeah, that's funny. And so everything, it really opened the door to all those interactive data exploration tools, like Tableau, or everybody knows about the demo of course, his name is going to escape me, Ernst Rosling, or even the newspapers now have interactive ways of exploring data. So, and typically all the prototype kind of led to the next one. So in this case, because we have the symposium every year, we had a lot of people from the community come. And for example, people from NASA. And they started this demo and say, wow, would that be really cool if you could do this for all our data sets, helping scientists find the data sets. But those systems, the early system where all the data was on local, on the hard drive, it had to fit in a floppy disk anyway. So it was all local. Well, now we have the internet, like 93, the beginning of the web, that says the web. So scientists were searching on the web for NASA data set that they could download or order somehow. So we came up with the idea of query preview because we could not do it all in a system like we had for the finder. So the same thing, to give you context, at that time, you were either using SQL. This is SQL to formulate your query. Like, people make mistakes, they can't remember the names, it's horrible. Or Progress, you had a form filling interface where you would type all the things you wanted, such area, such topic, this date. And at the end, they would tell us the most common answer is nothing. Because very common, you over specify what you want, so you get nothing, or you get like a million things. So the people, people were searching in the dark, in a way to simplify it. So our idea is what, so that's why 93 was we prototyped an interface that looked like this, where to help scientists find the topics of the data sets of interest in the global change master directory, who had, at that time, it was a lot, but like thousands of data sets. Now it would be much larger. And because we could not do dynamic query fast enough, we generated some previews. So for a few attributes, like here was topic, year, and area, we showed the number of data sets for each category. So if you picked North America, you know there was 2,500 data sets. And then you could select other things like Central America, it comes down. Oh, no, that goes up actually because you added an area. But if you select in another attributes, if I remember, it was like this one, radiance and imagery, then the number shrinks. And eventually you get a list. And from there, you could see the description of the data sets of interest, right? So what's interesting is that this demo, it was like, yeah, that's really cool. NASA implemented a real interface for their scientists on the web, but it kind of went dormant, no activity. But 7 years later, our dear colleague, Marty Earth from Berkeley and her students proposed faceted search. And it's really taking the ideas of the dynamic queries with a real database search behind. And here there was the example they used was searching for images of fine art search images. But look on the left, we have the different attributes, like the type of objects, the place, built places, different topics, and there is a little number next to it, right? And so that work really exploded, so that now, whenever you go shopping for anything, you see this type of interface, right? With the numbers, because there is no room for the bars, let's be honest. So we're stuck with the numbers. But you could order 10, whatever. So whenever you go shopping next time, think, I work where those ideas came. This is pretty cool. So you should be proud of HCIL. You should be proud of working here. And this is just an example. There is many other examples by other people. Not everything is going to have an impact, but some will. And the more you work on real projects with real people that are really in need, the more likely that's, I can't verify it, but our example shows that this is the case. You are more likely to have an impact, right? So you should give yourself a hug for that. So actually, do you have a question for this one, or can I move on? I see. Yeah, so stuff. Go ahead. Oh yes, they do. They refer to the paper. That's the way we do it in an academic fashion. But we had many discussions about this, and when I retired, Marty has shown a message saying thank you for dynamic queries. So there is. We are, that's a good news about our research environment. There is, after that, you never know when a company picks it up, because I would say all those interfaces are very visual. There is no problem just duplicating it on your own. We don't have secret algorithm behind it typically, right? So it's very hard to trace really who really read your paper or things like that. Yes?
But did HCIL ever try to patent any of these ideas?
So yes, we tried for some things, but in general, no. Let's say, but some things were patented. Like, for example, Ben does have a patent on drag and drop annotations. So you take a name and you drag it on a picture, on the face of a person, for example, and that was. Maybe at the end, Ben is there actually. He could tell you more because I don't have an encyclopedic memory. I can't remember the detail, but some big company licensed it from the university. So there are some success stories.
If I can jump in, just,
yes.
For that one, yes, the patenting of tagging on photos was the university owned that patent and did license it, sell it to a patent aggregator. And there are dozens or hundreds of patents that cite that patent, but we got only a small fraction of the sale that the university made for $500,000 came back to the lab. That was a bit of a disappointment, but that's the way business works. And so, or the university works. But yes, Catherine nicely documented the ways in which we knew that things were put to work. We did get some clear indications that that was our work. But yes, sometimes it's harder to show.
Right. That's right. I mean, in the case of the toggles, nobody acknowledged anything. It's just the lawyers that just by chance found the video. Otherwise, nobody would even know. Right. So it varies a lot. We have had more success licensing software. I mean, and still not a big success. Nobody's rich out of licensing this. It's just we bought a lot of pizza with the license money. Yeah, let's do it that way. All right, I'll move on to the next one. Wait, why does it do this? Oh, here we go. So the next one is called Lifelines, for an overview of personal records. So here's the story. Another case where somebody from the Department of Juvenile Justice or somebody from the Maryland government comes to the open house, see our demos, and say, oh, we need to work with you because we really have a problem with interfaces. And then we go visit, and it looks like this. So just, I mean, context about the juvenile records. Imagine every time a youth, I mean, somebody who's not an adult, gets caught by the police for doing something bad, they enter the juvenile justice system, and somebody has to keep track of all the steps into the review or what they did, blah, blah, blah. And everything was entered with screens like this. There's many things wrong with this screen, but for us, we saw, oh, there is a lot of dates, and clearly they want an overview of everything that happened with the kid. So we came up with the idea of, it seems completely natural now, but you know, again, at the time it was new, of putting all that information on a timeline. So at the end, and for the little story, so Anne Rose was hired for this project, and that's our interface, and it's a long time ago, and we're very proud of it. So the summary is here, and we could from this access all the details, but people like lists, so we also give the list. But the idea is that you have a timeline, so that gives you the age of the demo, 1995. This is today of that time of the demo, and we could see all the cases. So this poor kid was called, of course, there was a lot of acronyms, but where is my cursor? Breaking and entering. It was dealt with informally. They didn't send it to jail. Another breaking and entering is stole a car. This was handled formally, meaning that it went to a judge. I can't remember the exact detail, but in this case, we could see the color, the thickness was the severity of the accusation, really, and the color shows how deep it's going into the legal system, really. So it got darker. And you can see this is the name of a jail for juvenile offenders. So he went to jail after going to a drug abuse rehabilitation, probably. There's some red events, like a red here for medical. I remember it was this is fake, of course. We had to come up with a non-real example, but this would be a suicide attempt. This was then he's released. There is another case, etc. Today we could see where the cases are and what's pending. And if you need to do your report, like here, boom, you click on it, do your report. So the idea was in one screen, you summarize all the data that is available about this kid. And that's one of we compared it to the equivalent all-in table data, not as bad as one, but the best possible table. And it was very clear to show a quick benefits for this, except for getting the details. You still have to go and click on it. But that was one of the interfaces in a way I'm more proud of because it's simple. Everybody gets it. You don't need to train people really, except for some of the details. And it's very effective. Right. So another example of how things work. We do the paper, it goes to Kai. I present the paper at Kai. And at the end comes to us somebody from IBM, John Carrot, who says, oh, this is great. Could you do the same thing for medical records? So we said, sure. we'll expand the work on medical records. So the next step was to do work with IBM and with Kaiser Permanente because IBM was developing really one of the first electronic health records for Kaiser Permanente. No, I mean, first in general, but they were working with Kaiser Permanente. So we went over there, learned everything about how doctors do their job and what's important. And that was one of the examples where here we have the problems, the allergies, the diagnosis, the complaints, the labs, the imaging, the medication. And we did a lot more work to make this ideas, more feasible. And I'm going very quickly because time's fly. Just to show some examples of interfaces. I don't know how old this is now, but it came after commercial interfaces that people built, using those principles of Lifeline with different facets that are here. I think this is still used, now it's on a tablet, and you could get all the details of a patient record when you would make your round in an hospital. This is a completely different topic that was used for transportation. The idea is that there is an accident on the highway and they record, it's hard to read, but like who is on site. So the chart unit, the fire truck is here. When did they arrive? When do they leave? Which lanes were closed by the accident? This is the level of traffic behind, on the queues behind. So this is done by the CAT lab. I know somebody at HCIL is working for the CAT lab, must not be here today. But just to show as example that this simple idea really traveled very well in a lot of places. And even today, I still, once in a while, I get a message from a physician who says, oh my God, I just found your Lifeline, saying paper from 1996, saying, this is wonderful, why don't we have this in all the systems? Sometimes what looks simple is very travels and has a lot of impact, right? Just to be clear, there is a lot of papers that we have no clue that anybody ever used it, or, you may still have references. So you have influenced your colleagues who did something else. You inspired them to do something, but you cannot, it's very hard to trace. Tree map. Some of you, I'll go quickly because you may have seen, I actually heard Ben Schneiderman talk very recently about the tree map art exhibit. But just to tell you a little bit of retell the story for those who were not there. This was given by, I say like we always like to work on real problems that people really care about. In this case, it was us. We had one hard drive for everybody in the lab, and it was always full, of course. So we had to decide, what do we remove? How do we make room in this thing? So Ben had the idea of tree maps. I don't have much details here, but the idea is that you have each subdirectory, top-level directory gets a rectangle, and the size of each box is proportional to the size of the file. And so they are embedded within the directory. So for example, this is the window directory, and within window, this thing is the largest file. So you could at a glance see where the big files are, right? And that was, that helped us. What's interesting for this demo, again, I'm going really quickly, is that that was very helpful for us. And we were convinced that tree maps were really fantastic. Everybody should adopt it. It should be for, everywhere the next day. But practically, it didn't really happen because, so we eventually figured like when we showed this demo, nobody cares about our hard drive. But if you show them their hard drive, then they're going to be more excited because they'll find problems. And, but still, they were still struggling until one day, I forgot his name. Martin Wattenberg was working for Smart Money at the time, had the idea of using tree maps for the stock market. So in this case, each block is a stock, and the size of the block is the market capitalization, that is the value of the whole thing. And the colors tell you if it's going up, that's green, or it's going down, that's red. So you could tell at a glance, what was going on, good or bad. And we have many examples this that show you a good day, a bad day, but you get the idea. Then suddenly, everybody, not everybody cares about the stock market, but at least even me who doesn't really care, I could understand what it meant. And so suddenly it became, everybody knew about tree maps. And from there, they really exploded widely. There was also some improvement in the algorithm. Like you noticed before, it was a lot of narrow and long. So, obviously there is, just having an idea is not enough. You need to polish it, revise it until it's really usable. But the tree maps now are everywhere. And this is just to explain what's in the corridor. So that was when we were trying to expand, scale up. And this in this case for tree map. So now it's a 1 million item tree map. And we could still see the kind of the big files. This was a bug that some memories that was not released, or no space that wasn't released. So like after a few years, it was huge. And so an enormous image database. And then if you look carefully, I haven't looked at it for a while, you see duplicates. Like, for example, this one is probably a duplicate of this one. So when we did this, they found like thesis of PhD students who had left, but they had multiple copies of their thesis. And, with big files, it could take a lot of space very quickly. So it makes it possible to see what's in your hierarchical information. And it's really, there was also a fair number of commercial successes earlier on, like the Hive group, which still, created their own software. So that's the case. We license the tree map, and they license it. They pay for a license, but they never used any of our code. They actually rewrote it. So often what we like to describe our prototype as inspirational prototype. You see it, you could play with it, you could put your data, try it, and then you're gonna go and build your own system, right? And it's in a lot of now it's in Tableau. It's really in a lot of places. You find tree maps everywhere, including in your hallway. Whereas this is an attempt to do a success actually in doing tree maps that actually look beautiful, but they're all based on real data.
You have tree maps and faceted search in this one.
Oh, you do? Yeah, you're right. That they have some selector here. You could choose your copy. You want dark copy or light copy, etc. Oh yeah, and here too. You're right. That's right. They put those in here. You're right. I forgot about this. Yeah. So practically, I could stop here. I think I had more, but mainly I want to say thank you because of course, it's not just Ben and I's work, even though we really have been in the lab the longest. There were a lot of people involved. And there is a cool picture of Ben representing about when I arrived, that old terminal for reading emails. There was a modem, an old typewriter. No, at that time it wasn't old, but so just things that really changed. And then the other thing is that I wanted to insist that that's right, all IDs have an impact. But in general, the most important thing for us, the things we are the most proud of are the students and what you have become. So that's a huge part of the impact of the lab is how do you, inspire and train students to go and do better things in the real world. So again, give yourself a pat in the back. We're all doing good work. There were many other people that were involved in the lab. Some have come and gone, but there is really, we look forward to the next symposium and invite your colleagues, invite your friends. Invite the community. This is how you influence others, and they're going to go put your idea to work, and they're going to come back and ask for more. All right. I'll stop that and let's do more questions.